Hello, my students in grade 7. I hope you are all doing good. Today we have a math lecture, and this math lecture uh, is a new lesson in grade 7. So now I'm sharing the screen with you. As you can see, this lecture is about prime numbers. So this is our lecture 2, prime numbers. And as you can see, I've divided our lesson into 2 parts. This is part 1, and later we'll talk about part 2 of our lesson. The objectives of prime numbers: number 1, we'll define and learn what are prime numbers, why do we call them prime numbers. Number 2 objective, we'll identify composite numbers. Number 3, decompose a composite number or write a composite number as product of prime factors using an important method we learned this year. It's called the method of prime factorization. So we start with prime numbers. Why do we call these numbers prime numbers? Previously, we've learned even and odd numbers. Even numbers are all the numbers that can be divided by 2. Odd numbers are the numbers that we cannot divide by 2. Now, what are prime numbers? A prime number is a number that can only be divided by 1 and itself. So these numbers, we can only divide them by 1 and themselves. They have no other divisors. So a prime number has only 2 divisors, 1 and itself. As examples of prime numbers, 13. 13 is only divided by 1 and 13. So if I divide 13 by 1, it gives me 13. And if I divide 13 by 13, it gives me 1. Then 13 is a prime number. Also, 11 is an example of prime numbers. It's only divided by 1 and 11. 5 is only divided by 1 and 5. It has no other divisors. Then 5 is also a prime number. As examples of prime numbers less than 100, I want you to memorize the first 7 from 2 to 17. 2, 3, 5, 7, 11, 13, and 17 are the most important prime numbers that will be used in our calculations. It's very important to know that 2 is the only even prime number. We have many even numbers, but the only even prime number is 2. 0 and 1 are not prime. So 0 is not a prime number and 1 is not a prime number. What is a composite number? A composite number is the opposite of prime number. A composite number has many divisors. It has 1 as a divisor, it has itself as a divisor, but it has other divisors than 1 and itself. So a composite number is a number that can be decomposed into prime factors. Any composite number can be written as prime factors, and we will learn how to write composite numbers as prime factors. Let me give you examples of composite numbers. 4 has divisors 1, so 4, all the divisors start from 1. So 4 divided by 1 is 4. 4 divided by 2 is 2. 4 divided by 3, it cannot be divisible by 3. So 4 divided by 4 is 1. So the divisors of 4 are 1, 2, 4. So how many divisors does it have? It has a 3. It has more than 1 and itself, then 4 is a composite number. 6 has as divisors 1, 2, 3, and 6. Then 6 is not prime, it's a composite number. 15 has as divisors 1, 3, 5, and 15. Then 15 is not prime, it is composite. So 15 divided by 1 is 15. We cannot divide 15 by 2. 15 divided by 3 is 5. We cannot divide 15 by 4. 15 divided by 5 is a 3. It cannot be divisible by 6, 7, 8, 9, 10, 11, 12, 13, 14. So 15 divided by 15 is 1. So it has how many divisors? It has 4 divisors. Then 15 is not a prime number, it is a composite number. I wanted to remind you of criteria of divisibility because they help you a lot applying the method we'll learn in a moment. So we have taken before, what are the criteria of divisibility? How can I know if a number is divisible by 2, by 3, by 4, by 5, by 6, by 9, and by 10? We should memorize these criteria because they are helpful while we are working. So a number is divisible by 2 if the ones in this number is even, it's 0, 2, 4, 6, or 8. A number is divisible by 3 if the sum of digits, if we add the digits of this number and the sum is a multiple of 3. By 4 if we look at the ones and tens and they are a multiple of 4. By 5 if the ones in the number is 0 or 5. By 6 if the number is divisible by 2 and 3. By 9 if the sum of digits is a multiple of 9. By 10 if the ones in the number is 0. Now, what is the method of prime factorization? This is very important, not only for this lesson, also for other lessons. So how we decompose or how do we write a composite number as a product of prime factors, many prime numbers multiplied together using prime factorization. So any composite number can be decomposed or written as a product of prime factors using prime factorization. Now we'll start with the method of prime factorization. I'll give you an example. Given the number 24, 24 is not prime, it's composite. So let's decompose it into prime factors. How do we do this? We write 24, the given number, and we draw always a vertical line, only this. So applying the criteria of divisibility, always we start trying if this number, if the given number is divisible by 2. So is it divisible by 2? We look at the ones. The ones is 4. So 24 is divisible by 2. So I write 2 on the other side of the vertical line. So 24 divided by 2, the answer is 12. So I write my answer down under 24. Now I have 12. Also 12 can be divisible by 2. So I write 2 on the other side. 12 divided by 2 is 6. Also I continue. 6 is divisible by 2. So 6 divided by 2 is a 3. Now 3, can we divide it by 2? Of course, no. 3 is divided by 3 and the answer is 1. When does my method of prime factorization finish? It finishes when the answer down here is 1. So here, the numbers put inside this box, these are the prime factors of 24. So what do? I say 24 is equal to 2 times 2 times 2 times 3. But we have studied before the repetition of multiplication is written as power. So how many times are we multiplying 2? It's multiplied 3 times. So I write as a product of prime factors 24 equal to cube times 3 because the 3 is only written once. So 2 cube came from 2 times 2 times 2. I've written it as power. So how do we apply the method of prime factorization? To decompose a natural number into prime factors, we try, maybe it's divisible, maybe it's not divisible. So I try to divide this number starting from 2. If we can divide it by 2, then we write the answer under it. If we cannot divide it by 2, we try to divide it by 3 and so on. But never try to divide by 4 or 6 because we only try to divide by prime numbers. 2, 3, 5, 7, 11, etc. So here it's very helpful to apply criteria of divisibility I talked about before a slide. When does it finish? We finish the prime factorization when the answer of division down here is 1. So it finishes. As examples of prime factorizations, I want you to apply these examples alone on draft. So what do? You write 48 and draw a vertical line. You ask, can we divide 48 by 2? Yes, because the ones is even. Using your calculator here, you can use the calculators. It eases your work a lot. So 48 divided by 2, it gives me 24. 24 divided by 2, it gives me 12. 12 divided by 2, it gives me 6. 6 divided by 2 is 3. 3 is not divisible by 2, so 3 divided by 3 is 1. As you can see, all the numbers here are prime. So 48 is equal. How many 2's do we have? 2 times 2 times 2 times 2. We have written it 2 to the power 4 times 3. These are the prime factors of 48. Now 250 is divisible by 2. It gives me on calculator 125. By 3, by 2 we cannot, by 3 we cannot, by 4 I don't try because 4 is not a prime number. So by 5 it gives me 25. Also by 5 it gives me 5. By 5 it gives me 1. The answer is 1. I'm done. So 250 is equal to 1 time times 5 3 times, so I've written 5 cube. Now the next number is 420. 420 by 2 is 210. 210 by 2 is 105. 105 I cannot divide it by 2, so I try by 3. 1 plus 0 is 1, plus 5 is 6. Since the sum is 6, so it can be divisible by 3. By 3 it's 35. It cannot be divisible by 3 anymore. By 5 is 7, and by 7 is 1. So 420 is 2 squared times 3 times 5 times 7. Why did we write 2 squared? Because we have 2 times. Now 360. If I divide it by 2, it's 180. By 2, it's 90. By 2, it's 45. 45 cannot be divisible anymore by 2, so I divide it by 3. By 3, it is 15. By 3, it is 5. And by 5, it's 1. So 360 is equal to 3 times. So 2 cubed times 3 2 times. It's 3 squared times 5. So this is how we apply the prime factorization method. Okay, so till here our lesson is done. We are done with this lesson. Please, as I said, apply the exercise done on the last slide by yourselves on draft. This was our lesson for today. If you have any question after watching this video, please don't hesitate to contact me and ask me any question you have. Thank you.